So we're given this system and you have done a lot of math to get to that point. Now, here's one thing that you can do. You don't have to do this, but here's what I would probably recommend. I'm gonna make a u substitution. I'm gonna let u equal y squared. So I'm gonna rewrite this in terms of u. So instead of y to the fourth, I'm gonna write u squared minus 12u plus 16 equals 0. So I propose that these are the same because watch, the 16 is still there, the negative 12 is there. Instead of y squared, I wrote u because y squared is u. And instead of y to the fourth, I went u squared because u squared is y to the fourth. The reason I do this is so that instead of an exponent of 4 and 2, I see an exponent of 2 and 1. That way, we can use the quadratic formula. Remember that? Another thing you can try to do is you can try to take that and you can try to factorize it like that, but you're not gonna find numbers to turn this into that. So for that reason, I don't think factorization is what we want. So we're gonna use quadratic formula, which says, where A, B, and C are 1 is A, negative 12 is B, and C is 16. And right now, we're solving for U. Once we know U, we'll go here to solve Y. And once we know Y, we can go back to find X, because that's the goal, to find X and Y. It's just U that's helping us to get there. So let's take 1, negative 12, and 16, A, B, and C, and let's drop them in there to find U. So I took 1, negative 12, and 16, A, B, and C. I plugged them into the quadratic formula because it was the power of 2 for U. I did all this crazy math, and then I have this. So U has two values, 6 plus this and 6 minus this. But that's just U. Now what we're gonna do is we're gonna take this number, or these numbers, and because they are U, we're gonna plug them in right there. And that would give us this. So let's go down here now. So that would say that 6 plus or minus 2 square root 5 equals y squared. But we're trying to solve for y, so we're gonna square root. And so the square root knocks out the square, so this is just y equals, since we square rooted, it's plus or minus, so it's plus or minus the square root of 6 plus or minus 2 square root of 5. What I want you to see is that y actually has 4 values, and here they are. So check this out. Y has 4 different values, the positive and negative, and then the positive and the negative. So if you mix and match all the different possibilities for positives and negatives, here are all of the 4 potential values for y. So here is what I'm thinking. I am thinking that this original system of equations is going to have 4 solutions. XY, 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 4 points of contact. And we have already found all of the y coordinates. We just have to find all of the x coordinates. So what we can do is take this y value and go to the original system and plug it in. Maybe we can go into the equation that looks a little bit simpler. So as a matter of fact, look at this equation here. If I divide both sides by y, that'll say that x equals negative 4 over y. So what I can do is, since I know all the y's, I need all the x's. So I'm gonna take this y and plug it in there so I have its matching x. I'm gonna take this y, plug it in here so I have its x, and so on and so forth. So it's basically gonna be negative 4 divided by the corresponding y coordinate like this. So I propose that these 4 ordered pairs are the exact solutions to this system of equation, and here's sort of my backup. So check this out. I typed in the 2 equations there, and here's the graph, and you can see that they make contact 4 different times. That means that this system has 4 solutions. Here on Desmos, these are just like decimal approximations. I'm not sure what you want to do. These are decimals, but if you want the exact numbers, then they are what we discussed here a moment ago. So these are the exact solutions right there, and these are the decimal approximations of those solutions.